Hi, welcome to the Planetary Society. We're coming to you from Pasadena, California. I'm Barbara Turman, and I am the manager of individual giving here. We will be talking today and with Bill and Bruce, talking about that and the things that we can do as a community to help work to deflect and prevent against it. In the meantime, before we dive in, I just wanted to mention that we have a poster that's finally done. So we're really excited. We'll be sharing that with you this afternoon as an update. And we also have a new bundle coming. We're going to have a dinosaur bundle, which includes Chicxulub event. It'll be at a T, and we'll have 2 stickers. And we'll also have a Steve the Dinosaur pin. You talked to Steve in your opening.
In New Jersey.
In New Jersey. So we have had a bunch of questions come in advance of the live today. So I'll be asking those throughout our live.
No, a bundle is a bundle of merchandise.
A bundle of merchandise. A merch bundle. Yes. So I'm going to turn it over to you two. Can you introduce yourselves and let's dive in.
I'm Bruce Betts.
I'm Bill Nye.
Okay, we may have got that wrong.
I'm Bruce Nye.
I'm Bill Betts.
Perfect.
No, we're kidding. I'm Bill Nye, and I'm the CEO of the Planetary Society. And thank you all for joining in. What we do here at the Planetary Society is try to change the world. So I like to say we have excellent journalists. We educate. We're building a light sail spacecraft. We create, and we advocate. We go to governments around the world to get everybody involved in what we call our core enterprises, which is exploring planets. We're the Planetary Society. We advocate, write about, and create systems to explore planets, know more about the cosmos and our place within it. Then there's 2 things that are really near and dear to me while we're exploring planets. First one, I want to find life on another world in my lifetime. I mean, I presume we're going to go looking for life in the next 100 years, but why don't we just do it in the next 10 years? Can we just get it done? So I want to look for life. And then the third thing I talk about all the time, when I was in elementary school, nobody had any, when I was in college, nobody had any really good idea of what happened to the ancient dinosaurs. But over the course of about a decade, 1980, 1990, people realized that the Earth had been hit with a big asteroid. It didn't have the Planetary Society logo on it, probably. But the Earth was hit with a big asteroid, and it finished off the ancient dinosaurs. There might have been some volcanism in what is now the country of India, but that made the sulfur dioxide in the atmosphere and so on. But they were finished off by an asteroid. We do not want the Earth to be hit with an asteroid. We want to defend the Earth from an asteroid. And I like to say for that, we have to detect them. We have to find them. And the hilarious scientific comedy joke is, it's like looking for an asteroid is like looking for a charcoal briquette in the dark. They're very difficult to see, especially with regular optical or human eye frequency telescopes. But in the infrared, they do glow a little bit about 150 kelvins, 150 degrees Celsius above absolute zero. So with the right gizmos, you can find them. And then they do reflect some sunlight, to be sure. So then the other thing I like to say is we have to understand them. We have to get them. We have to get it about the asteroid. Is it a rock? Is it ice? Is it a combination of rock and ice? Is it some other happy thing? And then the third thing is we have to deflect it. Someday we're going to find an asteroid that's on a collision course with the Earth. We're going to have to give it a nudge. We're going to give it a push. And to do that, it takes the support of space agencies around the world. And space agencies work for you. They work for us. So we at the Planetaries like to say we connect you with space agencies. If you want to be connected with space exploration, whether it's learning about it, building hardware to explore space, or to get involved with governments, space agencies, and private companies that build space exploration hardware, be it satellites or telescopes, the Planetary Society is for you. So with that said, I'm going to hand it over to Dr. Bruce Betts, who is among the world's foremost authorities on asteroid. Dr. B, you are.
Well, thank you.
Oh, no, it is we who must thank you. Oh, no.
No, I thank you. But so should you lose sleep over asteroid impact?
It would depend on whether or not someone's seen one coming.
That's true. Generally, I would say no, unless we know there's an imminent impact, which we don't. But we should do something about it. And that's because asteroids do hit. They will hit again, particularly the smaller stuff hits all the time. There's over 100 tons of material hits the Earth's atmosphere every single day. But fortunately, it's mostly dust and sand size, burns up, makes pretty meteors. But on longer timescales, we have impacts like Chelyabinsk in 2013, where there was an asteroid that exploded in the atmosphere, about an 18 to 20 meter asteroid over Chelyabinsk, Russia. About 1,000 people were injured, windows were broken. So these things do happen. And the real significant thing about these as a natural disaster is it's the only large-scale natural disaster we can actually prevent, but we have to do something about it. And the Planetary Society is trying to do things about it. Others are trying to do things about it. We've got a 5-step plan for how to prevent asteroid impact with many of the points that Bill already talked about. We are trying to raise awareness of the asteroid threat with the public, with politicians, and this is where you can help us out through this Kickstarter, through the things, the materials, the t-shirts, the posters, just getting that public awareness out there that this is a real threat and it can be prevented is going to go a long way towards actually enabling the prevention of asteroid impact.
Low probability, very high consequence. So this is not something we drop everything we're doing and do nothing else but look for asteroids and get ready to fight. Something we do continuously in the background all the time. It's a long-range, very serious threat. So along this line, we had a Kickstarter campaign.
Yep,
yes,
we do. And we also have some questions from our community
in
advance of today. So let me dive in with one. So Ruby asked, what is the minimum warning we might have about an unknown asteroid that could hit the Earth? And does NASA have the capability of assessing just where it would hit and the amount of potential damage?
The minimum warning right now is it hit and we just noticed it, unfortunately.
Wow, we really noticed it.
That's
what happened with Chelyabinsk.
Yeah.
That asteroid.
All of Europe is gone. Wow.
Hey.
Didn't see that coming.
But that is why one of the main things is step one in the Planetary Defense, which is find them. And we're doing a better and better job of finding them and tracking them, figuring out if they're going to hit Earth. But the warning time you want is many, 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 many years. So you can actually
20, 30 years.
20, 30 years. So you actually have a lot of options in terms of ways to deflect the asteroid. If you do find an asteroid, and to answer the second part of the question, ahead of time, and you know it's going to impact, then yes, you do get an idea of where it's going to hit. It depends on how many observations you have. Very quickly, you'll nail it down to a corridor across the Earth because the asteroid orbits in a plane, so you know the strip, and then gradually you narrow down exactly where in that corridor the impact would occur. So yeah, with any reasonable warning time, NASA and others would.
By reasonable time, decades.
That's to prevent it. With days or weeks, you can act, depending on if it's that close and you can observe it enough, you can get a pretty good idea of where it's going to hit. But that's not what we want to do. We want 20, 30 years.
So Melissa asked, how far out can we see? Is there any development to expand that range? So is it about being far out that we see them, or is it about size that we see?
It's a combination. It's a combination of how big is it? It's just like things you look at on the Earth. How big is it? How far away is it? And how bright is it? So as you said, a lot of them are dark. And how fast is it moving? And so being able to combine those things, I mean, we detect things that are across the galaxy if you have Hubble Space Telescope, but when these things are all moving rapidly and are small and tiny and dark, it's tricky. So part of what we want is more observations, better capability, like Bill talked about, infrared space telescopes. We use the NEOWISE program now, but having one in the future that's actually designed to look in the infrared for asteroids will help in this respect.
Now, NEOWISE is Near Earth Object Wide Field Infrared Spectrographic mission, something.
Missed it by that much. No, you got all of it up until wide field infrared survey. Oh, now I'm not sure. Survey Explorer.
Survey Explorer. It's a satellite with
it.
a cool telescope.
So, Bill, can you tell us a little bit about the Neo Shoemaker grants? Because that's something.
Well,
that's
I would
happening.
defer to Dr. B on this, but let me start with set it up this way. An amateur astronomer is different from an amateur anything elser, an amateur golfer. Amateur astronomers don't just compete in a league or something. They actually contribute to the science. And the key to what makes it go is telescopes that are of reasonable size are reasonably priced. And you want to have as many telescopes observing any object as you can. So that means you want them spread all over the Earth. So what we do is find people who are amateur astronomers who are doing wonderful or extraordinary things, and we support them. Dr. B, how do we support them?
We support them through the Gene Shoemaker Near Earth Object Grant Program, which every couple of years we'll ask for a call for proposals, and we get proposals from all over the world. We then fund what are usually very advanced amateur astronomers, sometimes professionals around the world, and usually we're providing upgrades to their existing systems. So new cameras, new telescope mount, ability to robotically control their telescope so they can get more observing time. And these amateurs have done an amazing job. So they have found a lot of significant asteroids, but also particularly now with more professional surveys that are doing more of the finding, it's critical to have two other things, which is the tracking. So it doesn't help you to know there's an asteroid out there if you don't know if it's going to hit Earth. And that you require lots and lots of observations. And it helps to have people around the world to do that. And then characterizing, figuring out what the spin rate is, figuring out whether it's one asteroid or two, because it's kind of a bad thing if you go to deflect one and you find there are actually two.
So they're hard to see, and the Earth is turning, and we're all going around the sun. So this becomes a complicated problem when you're trying to observe a streaking object, but it's solvable. And what we need, as Dr. Beth said, we just need a lot of observations. Yes, Barbara.
Thank you. William asks, there seems to have been little progress on real planetary defense besides DART, D-A-R-T. What is D-A-R-T?
Dual asteroid test.
Is that the case?
Sorry, I should have studied my acronym.
That's okay.
But I can tell you what it is, which is a NASA mission that's in development that is designed to go to one of these binary asteroid systems and test the kinetic impact or deflection method, where you basically slam a spacecraft into an asteroid and by doing so change its orbit slightly.
It's kind of the Bruce Willis thing. Almost.
Almost. Minus Bruce Willis or the nuclear weapon. So you slam the asteroid. In this case, they would hit the smaller asteroid in a binary pair and then look for the orbital change that they induce.
But if it turns out that the asteroid is this gravel held together by their mutual gravity, and the thing you hit it with just goes right through, well, that's really not what you want. So the asteroid that's been chosen is strongly believed not to be of that nature. However, there are tens of thousands of asteroids that we don't really know what they're made of. Or how
and that's why we're characterizing them more and more. And they come in a lot of flavors, all the way from fluff balls to iron nickel solid objects. What was the rest of the question? I feel like
So they were wondering if the holdup on progress is a question of funding or policy or the technology science. Well, is it not there yet?
I disagree with there's a holdup on progress.
Okay.
It may be a slower progress than we desire, but you also have two missions which are getting near Earth asteroids this year, Hayabusa 2 of the Japanese and OSIRIS-REx from NASA. There are sample returns. So they're learning about the asteroid. They're not testing a deflection technique. So in that respect, that's true. Also, the other key thing, as I mentioned, is finding asteroids. So that's where we'd like to see a space telescope, but there is more and more work from professionals from NASA in survey telescopes and also from groups like ours and the amateurs we support doing observations. But yeah, there's a lot. It's not technology that is the limiting factor, or at least not the major factor. It's funding and resources.
And the other thing, the nature of rockets. There isn't right now. There isn't really a turnkey rocket. You don't go to like what do you buy that's big? On house, but an RV, recreational vehicle. You can go to a giant lot and buy a huge recreational vehicle and drive it home. Well, there's no place where there's a bunch of rockets in a parking lot and you just go out and get one and take it to your launch pad and shoot it. It takes a long time, and it is literally rocket science to aim a rocket at a moving asteroid binary pair. Not trivial. But the DART mission has got great potential. And just that it even exists is cool. You know, it just took a long time and a lot of lobbying, or let's call it advocacy work in Congress, U.S. Congress, to get that mission on the books.
And that's part of what we do. As part of our activities is advocacy, including for planetary defense, including for missions like DART. Because
you talk to normal people on the outside, it's very common to find people who are dismissive of the asteroid threat. I mean, quite recently. Well, it hasn't hit it for 65 million years, which is true. But there will be another one, and it's out there crossing our orbit right now.
As a non-science person, I've learned a lot in my time here at the Planetary Society. And one of the things that I think is really helpful for people to know is that there are people watching the skies in terms of these agencies. And you've talked before about the size that they're looking for and how there's certain things that are being seen that would be major devastations to us.
Yeah.
So more than 90% of the 1 kilometer diameter and above has been found. And those are true global catastrophe. I think we found all the dinosaur killer, I mean, massive global extinction 10-kilometer asteroids. What we haven't found many of are the smaller ones, including 500-meter asteroids.
You know, 500-meter. Cute little 500-meter giant rocks going 11 kilometers a second.
Yeah, so not just 500-meter, they're going many, many kilometers per second. And so when they hit, they make a big, big problem. And when you get down, basically anything down to around 30 or 40 meters, 30 meters will cause damage. The Chelyabinsk asteroid was 18 meters, 20 meters. And so there's more little stuff than big stuff, which generally is really good because we get hit less by big stuff. But we really have a lot of little stuff to find that's still big enough to do damage.
So let me refresh. If this asteroid hits the atmosphere so hard, how hard does it hit? It disintegrates or breaks it.
Eventually, yeah, it depends on the asteroid. And
the atmosphere is hardly different from a brick wall at these high speeds, right? So then it explodes. So how long did it take the sonic boom to get from the high in the atmosphere to the Earth's surface?
It was tens of seconds from Chelyabinsk, and that actually was one of the big ways people got injured, because they saw it, and they saw the bright flash, and the trail went to the windows. Like, what in the heck is that? And then the shock wave hit and shattered everything. Yeah. So there's a delay. If you have a large enough object, it doesn't care that much about the atmosphere. Even as a brick wall, it crashes through it and hits the ground or the ocean and causes potential tsunamis.
Yeah, and that's where people talk about preparing for an impact, as you move away from the ocean cities for a few hours until the tsunami went away. But I was in class, in Carl Sagan's class, when he talked about the Tunguska event, which people in those days called it the event, because nobody knew really what it was. But now, through the work of Gene Shoemaker and so on, people are pretty confident that it was what we now call an airburst.
Yeah.
Where the thing hit the atmosphere so hard. How hard did it hit? It hit so hard that it created a shock wave that blew down huge ancient trees, 100 kilometers, around 60, 70 miles in diameter circle. Just
I saw they said it was about 10 million, which to me helped put it into
10 million trees.
10 million trees.
About 2,000 square kilometers of forest were leveled. And this is in 1908 in Siberia. Fortunately, Siberia, not a major city, because it leveled trees over an area that's about 50% bigger than the city of Los Angeles.
Which is a big city.
It's a big city. It's very spread out.
Yeah. So this is a real serious thing. And that was in 1908, which you could say is a long time ago, but in the geologic scheme of things, it was like yesterday.
Yeah, we expect one of those to hit every few hundred years.
And so it was
years.
so remote. How remote was it? Nobody went up there and took pictures of it for 2 years. But if it happened in Paris or London or Moscow, that would be catastrophic, globally catastrophic. And so we don't want it to happen.
So this is a heavy topic that we know we've had to
Let's call
talk
it a
about
massive topic because we're in space and has no weight. Huh?
So let me shift us to some of the methods that what will we do when we do know about them? What are some of can you tell about the 3 deflection methods that we've talking about on the poster?
Well, one of them is just to smash into it, right?
Yeah, hit it with a spacecraft or multiple spacecraft if you need to push it more, called kinetic impactors, to use the fancy term, and that changes its orbit. So the key thing to remember about having asteroids not hit is you just have to move them a little bit in their orbit, particularly if you get to them very, very far ahead of time. So he will now demonstrate
the missing
something.
So
Oh, I see.
instead of
The
hitting-
asteroid missing. Missing is good.
Because the Earth is moving,
So you don't
and the
have,
asteroid is moving, so it's going to hit the Earth.
we
No, wait, we give it a little, and it misses the Earth.
knew
Exactly.
props would help you.
And so it's in space, so you don't hear any sound. Like you wouldn't even hear that.
Just go
It's
by.
really, really funny.
so you don't need to destroy the asteroid, despite the Bruce Willis theory. You just need to change its orbit slightly, particularly if you have many years warning. And so kinetic impactor is is one that DART specifically is looking into. We have hit an object with a spacecraft at high speeds, which was the deep impact hitting a comet. Tiny
We had a big
spacecraft.
party out here in Pasadena. We
It was
rented
fun.
a big auditorium. No, I was there with my predecessor, Lou Friedman, and we shot it with a copper cannonball.
Yeah, basically. And it did cause an orbital change, although it was a tiny copper ball in a big comet. But the second method you can use if you really do have 20, 30 years, you can actually use the gravity of the spacecraft itself. They call it a gravity tractor. And it will gradually pull the asteroid into a slightly different orbit. If you have enough time ahead of time, you can make those changes with a gravity tractor. Kind of last resort is you can go nuclear. And in that way, you can do it 2 ways. One is to actually detonate on or in the asteroid, fragment it, and have the fragments go off in different directions. But you can also do a standoff deflection.
Standoff deflection.
Where you detonate.
Except you're in space.
Away from the
Made him
asteroid.
laugh. I made him laugh. Not easy.
And then it vaporizes an upper layer of rock on one side of the asteroid. All that vapor pushes away, and you push the asteroid into a different orbit. There are other techniques we've looked at. We funded some activity at the Planetary Society looking into lasers.
Love the
beams,
laser bees, Bruce.
where they do basically a slow version of the nuclear ablation, where lasers keep pointing.
Except once again, just
They don't bust. They just
Now, people were asking, I didn't put one of those questions in the list, but people were asking about, could we have lasers here on Earth that are just shooting out into
boy,
space?
it's a long way out there.
It needs to be out in space,
Yeah,
like the lasers
probably.
or anything, right?
It's just too far out.
in some theoretical sense, but you want to get to the asteroids before they're near enough to Earth to be able to use lasers on Earth.
Okay.
You want some margin.
So the laser bee concept was a bunch of small spacecraft that would have solar panels, collect sunlight, make electricity to drive lasers to hit the surface of the asteroid and cause it, the verb is fabulous, to ablate, to burn off in Latin. And like a heat shield, re-entering the atmosphere, heat shield is an ablation heat shield. And so you burn off the atmosphere, the surface of the asteroid, and the momentum of the burned off stuff would give it a nudge. It's a cool idea. And I won't say the technology exists, but you can see it from here. It would not require some extraordinary breakthrough in quantum mechanics or something, or time travel. We could build such a gizmo, or a swarm of gizmos.
So Stephen asked, which asteroid measurement has more impact? Pun intended. he
More
said.
impact. Get it?
Mass, surface area, density, or shape? What is the smallest size asteroid being considered for intervention?
I assume he means in terms of impact to the Earth, and so the 2 key parameters are mass and velocity. And the velocity,
surface area isn't your big deal.
No.
Not your big concern.
No, it's because it's an energy issue or momentum, so it's mass that you care about more. Now, the makeup of the asteroid does matter, particularly at smaller sizes. At bigger sizes, it doesn't matter as much. So smaller ones are more likely to airburst, which still cause damage, but not as much. Whereas more consolidated ones, or the 4 or 5% that are iron nickel, like what hit in Meteor Crater 50,000 years ago, that allowed a smaller asteroid to make it all the way through to the surface, about a 50-meter asteroid, but it was iron nickel, and so it did more respective damage. But to first order, it's the mass that you care about and the velocity. Velocities vary, but they don't vary nearly as much as the mass of the object. So we tend to talk in diameters or mass, related to mass.
Okay. Bell asked, what happens to the debris caused by deflecting an asteroid? Could we create another threat by defending against the threat?
Well, so you want to, if you do this mythic nuclear option, you want to be wary of fragmenting something and putting a new object on a different collision course. So that is an excellent question. And the answer is it absolutely, for certain, absolutely depends. And so don't we have a Kickstarter thing going on? What are we doing?
We do have a Kickstarter thing going on. That's where these questions are
Yeah, but how are we doing?
Oh, I don't know. Ding, 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 ding. We
are on the Earth, and we do have
we have a goal of 50,000, and we're at $49,284 from 1,100 backers.
So we need $716.
Yes, we do. Good math.
So hey, we need $716, everybody. Do I care about me? No, it's you. And it sounds like a freaking PBS station, but every dollar helps reach our goal. And what we'll do with this money is try to save the Earth. Is that a big deal? Maybe not just for me or your political opponents, but everybody. We don't want the Earth to get hit with a big thing. The asteroid that hit, or perhaps a cometary body that hit in Chicxulub, Mexico, before Mexico was a country, is thought to have caused an impact so big. How big was it? That the ejected material, the ejecta, formed a cone of this rock and debris that was bigger in diameter than the Earth. I mean, that's a hit right there. Yeah. And the reason it's possible is because of the crazy speeds that these things go. They're going around the sun, and if with enough gravity, just as we are, to get around the sun, to get 1 billion kilometers every year. Happy birthday today to whoever it is. Somebody had a birthday today.
Happy birthday.
You just completed another 1 billion kilometers around the sun. Way to go. Anyway, to go 1 billion kilometers a year, you got to be humming. And the Earth is, except no sound again. The Earth is going around the sun. Nicely done, Doctor. And so the asteroids are going at least that fast, and sometimes in the opposite direction, essentially. And so you get these crazy closing speeds that can create these very, very high energy impacts.
And those are bad.
Yeah, those are bad for us.
That.
Just want to give the technical clarification.
And we always say hilariously, you got to save the Earth. Well, the Earth's going to be here. No matter what we do, what we want to do is save the Earth for us, humans.
So Riken asked, are there any new missions set to land on an asteroid like the Rosetta mission did on the comet? Does the Planetary Society have any current projects planned to study asteroids and how they could potentially benefit humanity?
A lot of questions. To start with, yes and no to the landing on asteroids. Both the Hayabusa 2 mission and the OSIRIS-REx mission, which are reaching their asteroids right now this year, will be doing sample returns. So they will go down and sample the surface and then come back up, put the material in a sample return capsule, and return it to Earth.
Landing in
for
Utah.
Analysis.
Landing in Utah.
Yes.
With no parachute. The people have worked this out. Just a tumbling disc of drag. And they land well enough. It's amazing. So there are 2 sample return missions already.
I'm guessing the other one lands in Australia.
Is that right? Is that a true fact?
That's where Hayabusa. It is.
Yes,
Hayabusa landed in Australia. and OSIRIS-REx will end here. And so
anyway, by supporting the planetary site, we will support our grants to amateur astronomers who are looking for asteroids, which is the huge, key, gigantically important main first step. There are many more asteroids to find than there are to deflect.
And also, because it asks about what we're doing, is we're also, in addition to that program, we are a primary sponsor of the Planetary Defense Conference that brings together experts in all aspects of the problem.
Plan D-Con.
And we also are doing
March?
activity. It's next April.
Next April.
And we're doing activities tied to educating the public and public awareness, like this Kickstarter, like having these posters, like having these T-shirts and pins and other products, but also like our 5-step plan online, like our printable infographics online. So we're working lots of aspects of the issue.
Awareness is the key thing. You know, I've gone to Congress several times in the last 2 years, and I've spoken about this issue, and people nod. And once in a while, you'll find the staffer or the member of Congress or Senate who gets it, who understands the problem. But we met one guy who said, well, until you can go faster than the speed of light, I mean, I'm just not really interested in anything. And you're just like, Congressman, sir, really, we can't go faster than speed. People have been thinking about this for quite some time. People with even more experience in science than you have in legislating. And we're not building anything to go faster than light to catch up to an asteroid. We'll get to that. We'll get to that problem. So it takes education. And that's what I'm going for. We have to raise global awareness of the threat of an asteroid.
So Kevin asked, and we'll get to that in a second, but Kevin asked, is there any formal communication between nations in preparation for possible asteroid collisions?
Yes.
So that speaks to the conference that you just talked about.
Yeah, that's exactly what the Planetary Defense Conference is bringing together people from all around the world. Planetary Society was part of a United Nations activity called Action Team 14.
Action Team 14.
And
it's called an activity. It's all this bureaucratic, sort of roughly a mixture of English and French. Okay, activity. But I mean, we're gonna try to deflect an asteroid thing. That's an activity. Yes, we'll be participating in an activity to save the world from death. Oh, cool. Nice activity. But we're going to do it with Action Team
14. So we on Action Team 14 made certain recommendations that miraculously, after only many years, went through the bureaucracy of the United Nations. And out of that grew 2 different entities with impossible to pronounce acronyms, one of which brings together all of the spacefaring countries, the spacefaring agencies, to talk about ways that what they would do if there is an issue. And then the other, the International Asteroid Warning Network, bringing together groups around the world to coordinate observations and activities in that respect.
So what the big thing is, what can the community do? So obviously back this project.
Well, this Kickstarter, man.
That's a big one.
That's what you should be doing to be happy.
We want people to do and need their help with.
That will make you happy to back this Kickstarter campaign.
So we do have Christine asking, what can I do in my community to mitigate asteroid threats?
Oh, so get the posters, get the merchandise bundle, wear your T-shirt proudly, put the poster up in the classroom, and just start talking about it. It's a fun thing to talk about at a party. It is. It's fun.
It is. And,
asteroids are fun in a way. No, there's 2 things everybody loves: dinosaurs and space.
And this brings them together.
It does. It really does. I'm not joking, you guys.
Bill, did dinosaurs have a space program?
Well, if they did, it wasn't good enough. I'll tell you that. No, really. I mean, how technologically advanced were the ancient dinosaurs? I mean, we haven't found any evidence of tool making. And the Tyrannosaurus especially had short arms with which to make tools. But it really is a remarkable thing. And then if you want to keep expanding your cosmic view, one of the deep questions that Enrico Fermi asked, who's a nuclear physicist, well, if there's all these stars and having an alien civilization is so probable, because there's so many billions of stars and billions of galaxies full of billions of stars. Where are they? Where are the aliens? Well, maybe a civilization, I'm not kidding you guys, maybe a civilization has to reach a certain level of technological expertise so that it can deflect an asteroid. And if they never do that, if the civilization never does that and gets hit, then you never hear from them. It's like Control Alt Delete on a laptop. It's like wipe on an Apple machine. So for civilization, so it's a real threat, and we really appreciate your support. So if you're watching this on your electric internet machine system there, check out the Kickstarter campaign. How close are we?
Let's see.
I'm hopeful over here.
We are at 49,400.
We need $600 to make 50,000. That's cool. Thank you all.
Very cool.
I mean, $600 isn't that far in the scheme of things. And we really, really appreciate it. So, man, this could really, it's fantastic.
We have another question from a different Bruce, and he has asked, what can amateur astronomers do to actively assist in finding space rocks?
Oh, here's your man.
Of evil intent, he said.
Of evil intent.
I love that.
Space rocks. Evil. They have, their eyebrows are like this. Yes. So, Dr. B, tell this amateur astronomer, engage this person on how we can save the world.
One is use your expertise to spread awareness. Two is advance your techniques, your observational capabilities. And the trick with asteroids is they're not very bright. They're stupid, but they're also just not, they just also don't reflect very well. Yeah. And so it typically requires a fairly large telescope, meaning a half-meter telescope, and
that's pretty big.
An advanced camera to really get
get
data that really contributes to the field. You can see the asteroids with the bigger asteroids with a lot of telescopes.
If you know what you're looking for.
Yeah.
Do you need one that slews that goes across the sky with the asteroid, or you just take a bunch of pictures?
No, for most it's taking a bunch of pictures, and so the way you find an asteroid is that you take picture after picture of the same place in the sky, and then you look for stuff that moves. Now, most of the stuff that moves has already been discovered, so you got to track that out. And then you take those observations and you submit them to the Minor Planet Center, and they distribute them out to the world to go observe more. So learning to advance your techniques and capabilities to be able to particularly do things like follow-up observations. So when there's an announced discovery, it'll go to the Minor Planet Center, and then they'll ask for more observations.
They'll send you a note. We used to be a telegram, I guess. They'll send you.
They won't send you a telegram.
An email that says, look at this part of the sky to track this thing. And this is where all the astronomers around the world, amateur astronomers, can do extraordinary things because of the huge number, or the potentially large number, of telescopes looking at the same object. So please get on board with this. Dr. Betts is your man to connect you to the global network of small planet observers. And I'm sorry. Really appreciate your interest, because you really may save the world. I mean, it's a real thing. Go ahead, Barbara.
So I wanted to share one more question before we sort of wrap things up today. Dan asked, and I'm paraphrasing his question. He's a teacher, and Dan wants to show his students the importance of knowing about the threat and having a plan in place. He's hoping to inspire the next generation to do more about this, and wonders whether this could be cross-curricular and involve writing to local politicians in addition to the physics.
Oh, yes. Yeah. So if you want to write to your politician, go to our website, planetary.org, which of course is your homepage, and you'll find an advocacy section, and you can find your legislator, your congressman, senator, member of Congress, senator, that to whom your kids, your students, and you can write. That is exactly what we need. As I told you, the remarkable gradient of understanding in the U.S. Congress. Some members and senators really get it, and others are dismissive of it. I mean, because they got a zillion other things to do. But this is something we want to emphasize continually, so that eventually, in the next few years, humankind is ready to act when one is identified.
So the bottom line is we want people to join the Alliance to be a planetary defender. Bruce, can you tell a little bit about the plans ahead? We've got a new website.
We got a new website, planetary.org/defender.
New page.
New page.
Section.
Sorry.
Yeah, no, don't be sorry. It's okay.
I know, I keep saying that.
And you can find more information there, and also ways to get involved. Sign up for information, newsletters, to ways to get involved with planetary defense, and get involved with the Planetary Society.
Well, I know the other day you guys talked about how getting people to look through telescopes too. We have volunteers around the world that spend time setting up telescopes and giving kids the opportunity to.
Well, kids of all ages.
Yeah.
Yeah. When you see Saturn for the first time, it takes your breath away. And by way of example, and if you're an astronomer, if you're anybody, and you think you found something moving relative to the background stars, it is a thrill. I mean, it's just so exciting. You know, I interviewed both Hale and Bopp of the Hale-Bopp comet, and they just both described the extraordinary thrill of realizing they'd found a new comet, a new cometary body flying across the sky. So check us out. Check out the Kickstarter campaign. We are an organization that's the largest in the world for people interested in space who are not working in a space agency for a government. We are it. And it was started by Carl Sagan back in 1980 with two other guys, Lou Friedman and Bruce Murray. Bruce Murray was the head of JPL. He was your thesis advisor on your PhD. And what I always tell everybody, we are the real deal. We are realistic. We really evaluate real scientific undertakings in space exploration. We're not making extraordinary claims that are, well, they're not ever going to happen. We're the real deal. And so this is where Congress in the US especially relies on us. And we connect you to them. We connect you to other members of the society. And we also like to refer to a larger group of people we call the community. People who follow us online, read our website stuff without ever joining. But you should join. You should join the Planetary Society and be part of the future of space. We connect you to the cosmos.
And that is one of the reward options in the campaign for our Kickstarter for Kick Asteroid. We have lots of fun swag. We have a t-shirt. We have a new one coming with Chicxulub on it, with Dinosaur Impact Event.
New t-shirt.
Merch bundle.
An amazing poster that we'll be putting up the final picture of that today. And we just really hope that you'll get some of our great stuff to help you then talk and start conversations with people and begin to talk about this very important thing that we were trying to help spread awareness about.
Help save the world.
Yeah, how hard could it be? Yeah.
So with that, we're going to sign off.
Thank you all. Thanks for
gentlemen?
watching.
Thank you.
And thank you for all the backers who have been part of our campaign, and we're going to keep going. So thanks so much.
Thank you. There's lots on the website. Click around and turn it up loud.
Kick Asteroid.
Kick Asteroid. That's brilliant.